we need to take a look at like what your physical CPU is made of, right? So let's zoom in on the CPU because a lot of our talk here is going to be about CPU. So first of all, can you explain to us what a CPU is?
CPU is the brain of a computer. It
Mm-hmm.
it is most. They have cores and threads. Well, they have cores,
Yes.
and in those cores there are threads. Each
Mm-hmm.
thread is assigned a task,
Right. Okay, that's pretty good.
and so the more thread you have, well, normally, I'm not sure, but this is what everyone has been telling me. The more threads you have, the better it is, or the more cores you have in general, the
Depends
better it is.
depends what you're trying to do.
Yeah. So that's why I said I think.
Right. So this is pretty good. Like this is a pretty good introduction. So yeah, the first thing is the cores. So you have two important, like the two most important metrics to measure what a CPU is capable of is the amount of cores, number of cores, and the clock speed,
Yep.
right? Clock speed. Can you explain to us what the clock speed is?
It is, well, I guess how fast your CPU, how fast or how performant your CPU
Mm-hmm.
can be.
So it's actually so the reason it's called clock speed. It's a weird name, right? Talking
Yeah.
about clocks. Um, the reason it's called a clock is because so okay, I'm gonna do a very simple demonstration of what a CPU core looks like. Like this is super abstract, okay? But like
Okay.
we're gonna talk a little bit about it. We're gonna do a tiny bit of electronics here. So in electronics, we have what we call gates, which are logical gates. One of these gates is the invert gate, which means whatever signal is inputted is inverted. The output is inverted.
Okay.
Okay. So then what you can do something cool where you say, okay, I'm going to input a signal for like a very short amount of time, right? So I'm gonna. So first, one is means there is a signal, and zero means there is no signal.
Okay.
So I say, okay, I'm gonna input a signal, meaning the output is zero, right? And then I'm gonna cut the signal, and then the output becomes one. But wait, hold on. We've linked all of this together, right?
Mhm.
So if the output becomes one, it means shortly after the input actually becomes one and the output becomes zero. But it means that then the output becomes zero and the input becomes zero and the output becomes one, and so on and so forth. And so you go back and forth to doing 0, 1, 0, 1, 0, 0, 1 really, really fast.
Okay.
This is what we call a clock cycle. A clock cycle is when you go from 1 to 0 and from 0 to 1.
Yeah.
And so when you for clock speed, so this device here, this little heart, you can think of this as like the heart of the CPU. It's like it rebeats. It has a clock. It is a clock, right?
Okay.
So this is what we call the clock. And clock speed is measured in gigahertz. I mean in hertz. And hertz means how many times per minute. So for instance, a clock that is, I don't know, let's say 2 gigahertz, it means it's going to do 2 million, no, 2 billion, excuse me. It's going to do zero, is going to go through 1 to 0 and then 0 to 1 to 2 billion times per second.
That is a lot.
Yes, it is. Obviously, this is extremely simplified because then, like, the you can essentially get more power, more computation from a single clock cycle. If you like, I think it's between Zen Plus like for AMD processors, between Zen Plus and Zen 2 architectures,
Yeah.
you you have like I believe it is 15% more compute power per clock cycle. So even though at the same clock speed, it would be like you have 15% more clock speed.
That's a big improvement.
Yes, it is. Like Ryzen 3000 series is no joke.
Wait for 4000.
No, man, I'm waiting for 5000 with DDR5 memory.
True, true. Fair point.
So, okay. This is essentially like this is an oversimplified. So this is a clock, right? And then
Yeah.
you've talked about cores. The idea is that in your processor, you have multiple cores. Each core has one clock. I'm going to draw a clock. So for instance, if you have a 4-core processor, your 4-core processor is going to have 4 cores, each of which has a clock. So a little device like this that goes through ones and zeros really, really fast.
Yeah.
And then the really cool thing about this is that if you have, so like you explained, yeah, if you have 4 programs, normally if you have only one clock, well, one clock can only do one operation at a time, right?
Yeah.
Going through from a 1 to a 0 to 1, so a clock cycle can only do one operation. So if you only have one core, one clock, you can only do one operation at one given time. The advantage of having multiple cores is that suddenly you can do multiple operations at once.
Okay.
Right. So for instance, in the most basic example, we have 4 cores. That means we can run 4 threads. And this is what you talked about. A thread is like the measure of how many applications, how many operations can I do simultaneously.
Okay.
So with just what we've seen so far, if I have 4 cores, I have 4 threads. That means I can run 4 applications simultaneously.
Yeah.
If I have more, let's like if you open the Windows, like it's the, let me see, I can show. Okay, yeah. If you check this out, if you check your task manager and you go under performance, you can actually see the amount of threads running on your machine right now. And you see it's 3,000, for me it's 3,000 something. Obviously, I don't have 3,000 cores. What it means is that there are 3,000 and something tasks running simultaneously on my computer.
Okay.
And then, so this is like from an operating system perspective, a thread is like a task. And then when your computer is, my computer is like, wait, hold on, I don't have enough cores to handle all of that. Essentially, the way it works is, so let's say I have 3,000 tasks. It's gonna one core is gonna handle one task for a given time, and then it's gonna pause it. It's gonna pause, and then it's gonna run another task, and then it's gonna pause, and then it's gonna move on to another task, and then it's gonna pause. Right? So I can only run, like the amount of tasks I can run simultaneously is dependent on how many cores I have.
Yeah.
Otherwise, I have to like pause in between tasks, in between handling tasks. Now, on top of that, there's another technology called hyperthreading. I suspect you've heard of it.
Hyperthreading. Yeah, I've heard of it, but I haven't looked into what it can do or what it is.
Threading. So hyperthreading, I'm not aware of the actual technical details of it. Again, I'm not so big on hardware. I'm more of a network guy, but my understanding of that is that when you have hyperthreading enabled, each core is capable of handling 2 separate threads. Right? So suddenly a 4-core process, this is why, for instance, if you check an AMD CPU, that would have 4 cores. Very often you'll see 4 cores,
8 threads.
8 threads, right? That means 8 threads. That means hyperthreading is enabled. Hyperthreading is something you can disable, by the way. And disabling hyperthreading increases your single thread performance.
Yeah, okay.
Right. So, for instance, hyperthreading is extremely useful for multitasking, but it's not always an upside. So I'm not aware of like the technical details of how it works.
Yeah.
But fundamentally, you can get, for instance, for heavily single-threaded applications, so that means one thread requiring a lot of process. So something like most video games, with a
Yeah.
few exceptions, such as I believe Apex is actually an exception to that rule. It's more multi-threaded. But for single-threaded applications, like most games, it would be beneficial to disable hyperthreading, go back to 4 threads, but then having each one of those threads be more powerful,
Okay.
right? By the way, this is why. So if I show you my CPU performance again, so I have a Ryzen 3900X, which is a 12-core processor. But if you count here the numbers, like the amount of graphs here, you can tell I have 24 graphs. Why do I have 24 graphs when I only have 12 cores? Well, it's because from the perspective of the operating system, if hyper-threading is enabled, then each CPU thread, each hyper-thread actually appears like a separate CPU core.
Okay.
If I was to disable hyper-threading, I would not see 24 cores here, but only 12. The 12 physical cores that I have on my processor.
Yeah.
Okay. So all that talk, now we understand. So if you open up your own task manager, I want you to tell me how many threads you have right now. Like how many threads does your CPU have?
Well, for now I only see one giant graph, even though it's a 6-core
Oh,
processor.
let's see. What's the option to? I don't remember what the option is to. Oh no, I didn't mean to do that. Oh no, that's terrible. What did I do? I can't even right click anymore. This is horrible. Do I press enter? Double click? This is horrible. Jesus, Windows. Okay. Okay, I just reopen it. Oh, there we go. No, that's not it. Hide graphs? Show graphs? No. I don't know. There is maybe options. Right click on the graph and reset to logical. Oh, maybe this one. Yeah, this is what you see,
Yep.
right?
Yep.
Okay, so you right click it, change graph to logical processors.
Okay. It is showing me 12 supposedly CPUs when it's actually the threads.
Right, so if it's showing you 12, then it's likely that you have 6 cores with hyperthreading enabled.
Yep.